Prove ABCD is an isosceles trapezoid. In order for something to be an isosceles trapezoid, you need to show two things. You need to show that these two sides are parallel, and you need to show that these two sides are congruent. So what I'm going to do is I'm going to find the slope of BC and the slope of AD and show that they're the same. Then I'm going to show the distance of BA and the distance of CD and prove that they're the same. Therefore, it's an isosceles trapezoid. Let's write out a few friendly reminders. The slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's going to come in handy for the whole parallel thing. The distance formula is a big square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so let's start out by doing the whole parallel thing. And I'm going to say that I need to show that BC is parallel to AD. So let's say the slope of BC, I'm going to use the slope formula. Let's let this be x sub 1, y sub 1. Let's let this be x sub 2, y sub 2. So y sub 2 minus y sub 1 is c minus c. I think I can handle that. Then I have x sub 2 minus x sub 1 is going to be b minus negative b. Double negative makes it positive. 0 over 2b is just 0. Makes sense because that looked flat to me. Now let's find the slope of AD. A similar thing should happen. If I call you x sub 2, y sub 2, and x sub 1, y sub 1, then I'm going to do 0 minus 0, another toughie, over a minus negative a. Oh, look, a double negative. Let's make it a positive. 0 minus 0 is 0, over 2a is 0 again. So, since the slopes are the same, I have now proven that BC is parallel to AD. Okay? So that was thing number one. Thing number two is I need to show that these two guys are equal in distance. So I'm going to use the distance formula to show that AB or BA is equal to CD. Compact disc, those of you 90s kids. D is equal, and let's rewrite it out so that I'm a little bit more specific. Let's start out with BA and show that the distance of BA is a big square root of, let's let you be my 2's and you be my 1's. So negative b minus negative a squared, negative b minus negative a squared, plus c minus 0 squared. Double negative makes a positive. Now, since space is an issue and time is money, okay, I'm going to use the idea of perfect square trinomials for this one, and I'm going to make sure that I understand that this becomes b squared minus 2ab plus a squared, and u are going to be c minus 0, which is just c, so plus c squared. If you're like, whoa, 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 what did he just do there? Perfect square trinomials. I'm not going to go any further than that because I know that when I do CD, that it's going to end up looking like the same exact thing underneath the square root. So what's the point of trying to clean it up? Okay, what's the point of trying to combine terms and simplify it? You probably can anyway. Let's keep that red going. CD The distance for that, big square root again. I'm going to let you be my 2's, let you be my 1's. That is going to be c minus 0 squared. Oh, I did it backwards, didn't I? Doesn't really matter. Plus b minus a squared. C minus 0 squared is c squared, so there's my c squared. B minus a squared using perfect square trinomials is going to be b squared minus 2ab plus a squared. So there it is, the same exact thing. So, and let's get rid of these rules because I won't need them anymore, even though they look so darling. I just showed that BA and CD are the same. So let me say that. So since BC is parallel to AD, and since BA is equal to CD, that tells me that ABCD is an isosceles trapezoid. All right, so that's coordinate geometry. You're not setting up a 2-column proof. All right, you're just showing the math that you need to show to prove that these guys are exactly what they say they are. Fun.